Hello everyone, welcome to this SDC session. So myself Sushant, maintainer at Soda project maintainer and senior architect at Huawei Technologies. And with me is Amit, who is a senior architect and Soda maintainer, Soda project maintainer. So in this today's session, we are going to discuss on some of the challenges and opportunities related to container data protection. Before jumping into the topic, so let's spend a minute or two in understanding what is the trend or how the current situation looks like for the storage as a service with respect to storage as a service and then the container storage as a service. So as per some of the studies conducted by different organizations and independent entities, so we can see a clear shift or the rapid transition happening to containers from earlier traditional deployment like VM-based or physical machine-based. And Kubernetes deployment comes on top with the different flavors of deployment like public cloud, private cloud, or hybrid cloud. And now more and more organizations have seriously putting their effort in real-time use case deployment with respect to container in containerized fashion. And if coming to market also, it is like it's a continuous upward for the container-based businesses, container-based deployments. So we can see like next few years, there is a very good projection with respect to container way of doing the things. So what are the key challenges for container data management? So as we have seen now, most of the containerized applications, if you see the nature of those applications, more or less they are stateful. That means they have something to persist with them. So data persistence is key requirement. And by the very nature of containers are ephemeral. That means the application might go down, come up, go down somewhere and come up somewhere else. But data is expected to be intact and it should be accessible at any point of time for the application to function normally. So this is another aspect. And when we talk about the storage needs, the provisioning can be from different storage systems with the different capabilities, and a lot of metrics or the capability factors will come into picture when we choose a storage. So heterogeneous storages are in the view, and hybrid use cases with respect to deployment and the distributed nature of the data and data being made to or expected to be available anywhere, irrespective of where actually it resides. What this means to the platform and storage vendors. So some people who are in this area of creating the solutions. So it is mostly seen as an end-to-end solution with the product ecosystem, end-to-end solution for data management with the capability of application awareness, how exactly application behave and how the framework should behave accordingly, and features and feature set and the whatever is supported should be following the service model wherein user or the user will be able to choose or make his model at his own wish based on his use case and deployments. So what exactly is container data protection? So we have already seen containerized application deployment. So when we talk about these applications, so they have a need of a persistent data with that also comes the protection of that data. That means safeguarding the data at any point of time, being it accessible at any in future or current purposes for the containerized applications. So if you translate this container application problem to a typical deployment on Kubernetes, That means an application deployed on Kubernetes. What are the data protection aspects that will come into picture? If you see the data, the application deployment to Kubernetes, the application can be viewed as software with its own set of configurations, which is required for its function to work. And when it is deployed in the Kubernetes, Kubernetes has its own way of managing the application with respect to maintaining some metadata with respect to the applications. And also the application will have some need for the persistent volume where it can keep its data. And this volume can be coming from any of the storage providers in a hybrid storage environment. So any software which takes care of backup or the restore is supposed to have supposed to take care of all these aspects of when it is dealing with the backup and restore. So what is available in Kubernetes for backup restore, or rather with what support Kubernetes started viewing this problem? So Kubernetes started using custom resource definition to what is called as volume snapshot object. And through the help of this volume snapshot object, Kubernetes allows the user to take the backup of data. When we tell backup data here, it is mainly in terms of a snapshot. That means there is a storage provider who is capable of taking a snapshot, and then the user will give a specification, and he will Kubernetes will make sure that backup is taken with the help of a provisioner. And then when the turn of restore comes, again, user will request, providing the backup info, user will request the Kubernetes to restore from the given backup. That time, the Kubernetes will again instruct the storage provisioner to recreate the volume and give it back to the application using the snapshot information provided. So that's not all, because data protection has so many use cases to handle, so many features to support. So there is a special work group called Data Protection Work Group, which have been working for quite a few years now, and they are putting their effort in bringing up different use cases, identifying missing functionalities, and working together to put up a design and proposal so that Kubernetes will become Kubernetes will enable itself to support the data protections feature. So what are the missing blocks as we can visualize from the Kubernetes perspective with respect to data protection? One is, as we have seen, it is whatever we have seen, it is about the snapshots. So, but the volumes needs to be backed up, not just a snapshot. And there should be a way of choosing or configuring different repositories where these backups can be kept, and also updating the information in the volume with respect to some of the data sources, or how the information or background of this volume on with respect to who created it, who can back up all this information, if to make this information part of the volume itself. And before executing the backup restore features, there may be a requirement, there may be a necessity to stop or start certain applications on need basis, and then do this backup and restore. And also some of the efficient ways of doing, such as change block tracking to avoid the complete backup, and volume group consistent snapshots, and some of the application snapshot backups. So these are some of the missing blocks identified, and this list keeps growing, and some of the things have been already finalized, merged, under review. So all these things are at a different stage of its life cycle. So if we see about what are the key backup and restore scenarios for the containerized applications. So as a user, backup may be, users wish maybe to take a backup at a different granular level, such as cluster level, namespace level, or at any other level specified by user. and choosing what and all to be backed up, what and all are not required to be backed up, where to keep the backup, and when to take the backup, whether it is immediate or and time-based or some other trigger-based backups. And during the restoration also, how to restore, whether you want to restore the whole backup or just part of the backup to be restored elsewhere, and also the location about the backup, whether it is in cluster, cross cluster. So these are some of the aspects or the key use cases that we can think of with respect to backup and restore scenarios. So data protection is not just this, but this is one of the area which we have elaborated here. Now I would like to hand it over to Amit to explain about how some of the work going on at SODA Foundation level with respect to container data protection. Amit, over to you.
Yeah. Thanks, Roushan. Hi, everyone. So in the rest of the session, I am taking you through the work which we have in SODA Foundation towards data production. Now, first thing first, SODA Foundation under Linux Foundation is actually a open source project which aims towards to provide an ecosystem where data management and data autonomy can be done for storage softwares. Now, under Shushan, can you please move? Shushan, could you please move back one slide? Thanks. So, for the data protection, SODA Foundation is actually currently has a lot of projects such as Delphine, multi-cloud for data management. But especially for data protection, recently SODA Foundation has added a new sub ecosystem which is SODA CDM. There we are hosting a group of projects which actually deals with focused towards a container workload data management system. And there we are currently focusing mostly for data protection. And the the recent development of the SODA CDM is we have recently introduced a new repository called Kahu. There we are working towards to build a framework for backup and restore solution for containerized workload in Kubernetes environment. Next to that project, next to that, aligned to those SODA CDM data protection projects, we have replication and data disaster recovery and observability in line coming in future. So now in next slide, we are gonna discuss a little bit about Kahu project. So the main focus of this project is to provide a framework for all the container workload deployed on Kubernetes for backup and restore. And this backup restore is actually is currently one of the key and most asked feature in the Kubernetes ecosystem as well. So we grab the opportunity to work parallelly with the Kubernetes ecosystem and data protection SIG and develop a framework so that multiple storage vendors as well as the backup and restore softwares can be plug in together to make a environment where a complete workload can be backed up and restored. Now, a little bit of note over here is the project is it is in very early phase, so you might find yeah. So because it is in early phase, so the features which we are discussing in this will you might not find implemented, but yeah, those features are in pipeline actually. So let's discuss the key goal and the features we are trying to achieve in the Kahoot for backup and stories uh, to provide a framework where metadata of the workload can be backed up. The sub the framework would like to support a backup with the snapshot functionalities. We would like to support also with the incremental and differential backup. The restoration of the backup at customized scope, like what kind of uh, uh, restoration you would like to have, like you want to have a complete backed up to be get restored, or you want a partial a set of resources to be get restored at the space level and the cluster level. So those kind of granularity are still being considered. Now we have a different the framework will provide hooks for quashing of scenarios. Then we have a backup and restore within the cluster and cross cluster scenarios. Then we have uh, then we have also thought of adding different providers backup, which will where a data can be backed up from one of the provider and can be restored. The same data can be restored on a volume which is being provided by some other vendor. Now we have application aware backups. Then again, one of the one of the exploration area which we are currently working on is encryption and compression aspects of the backup, so that the it could be the encryption and compression modules can be plugged in alongside the deployment, so that the user can choose what encryption and compression functionality they want to go ahead with, so that the complete data, end-to-end data, is being ensured from the for the user front. Now, further to that, as we have talked about multiple uh, requirement, I would like to say for the Kaho project. So the core of this complete requirement is a storage provider framework, which provide a pluggable approach for different storage vendor and different storage backup software come together and get plugged in to the storage provider framework, and eventually provide a integrated solution to the workload, so that the workload can be backed up and can be restored across the cluster or across the vendors and different deployment scenario, like hybrid scenario, the cluster scenario, in cluster scenario. So the key features over here is again the pluggable integration, support of coexistence of multiple provider, flexible life cycle management, and then integration of product with some more capability to realize that the offloading and complete backup restoration operations can be done. Now, we have thought of adding some of the automation and orchestration uh, schedulers. I would like to say where the backup can be managed based on different scenarios. The backups can be a scheduled backup, or it could be a backup event-driven backup, or it could be a policy-based backup. And there is a special scenario where the user can have a custom service plan. The backup services can have backup software can have a backup service plans where a user can choose to have those plans, and based on the plans, the backups can be achieved by backup softwares. Okay, this is all we have for the theory part on the cow system. Now we are moving our discussion to demo. Uh, so let me share my screen. Shishad, could you please enable me to share my screen?
Amit, okay, okay. Please check.
So, for the sake of time, I have already set up the complete Kahoot system, the basic demo part. Now, in this demo, what we have deployed is we have two uh, workloads deployed. So these two workloads are basically handling a, basically underneath the users CRDs, and those CRDs are actually the definitions of what all resources you want to backup. So basically, the backup controller is going to read all those CRs, and eventually it would trigger uh, a workflow. And in the workflow, it would currently we because this has been recently started been developing, so we have limited our focus for backup controller on metadata backup current. So it would currently in the current state, it would download all the metadata of the respective resources which has been requested for the backup. So it will fetch all the metadata and will hand it over uh, to the different backup repositories to be get stored. So if you'd like to see the internal of the process, how the processes are communicating with each other. So this is our controller. So uh, uh, as per the request, whatever resources are being requested for getting backed up is being monitored by this controller, backup controller. It would fetch all the metadata and will hand it over to the meta service. So we have defined a meta service now from this command line RP. Again, further further the second workload we have is actually the meta is the backup repository. Now, backup repository is being deployed alongside with the helper sidecar, which is a meta service sidecar. So there is a defined interface for meta service. So backup controller is uses that interface, which is currently a gRPC interface, and hand over all the metadata information to meta service. What meta service does is it archives all the information coming from the backup controller and put it into a file, and that file is further being pushed up to the backup repository. Now again, backup repository has a set of drivers running alongside. So those drivers has a responsibility of taking the data from meta service and uh, store it into the backup repository basically. And the communication between again with the meta service and the backup repository driver is through gRPC, and there are defined interfaces for those gRPC. Now let's just see how we can how a user can request a particular workload to be get backed up. So uh, we have examples over here. So if we just see look into the example, this is the we have a CRD defined for backup, and this is uh, the resource definition of that particular workload to be get backed up. So what we have over here is we have different filters defined. What kind of resource basically for the sake of this demo, we have just given a basic uh, filters over here. so which is currently include resources, include namespaces. There are filters for exclude resources, exclude namespaces. There are filters for based on the labels. There are hooks as well. So those is all all those all functionalities are there, but for the sake of simplicity, we have only included the resources part and the namespace part. So for this demo, I'm just going to show the resource. So basically, it is requesting all the ports which is defined inside this default namespace to be get backed up. So let me just let's just see if backups are available. So we do not have any backups available. Let me request. Let me request. Basically, let me submit a backup custom resource to the Kubernetes so that the backup controller can read the information and start its process of creating a backup uh, to to the and to the backup repository. And just before submitting the backup resource, let me tell you the setup of this particular system, wherein we have a NFS backup repository and the driver, the backup repository driver is connected with the NFS server, and that NFS server, so the driver will gonna store that information and the backup data to the NFS shared path, and that the same shared path is being currently mounted in the current system to the temp NFS folder. So let me just uh, grab a mount for you. So you can see this is the NFS share, and it has been mounted on temp NFS on this particular system. So if you see this uh, directory, currently it should be empty. Yeah, oh, so we have already a demo, backup demo available. Let me just delete it. Uh, so it should be clean by now. Yes. Now let me submit a request to take a backup. So yeah, let me submit this. So now we can see a resource being submitted. You can see that the backup demo is over here. We have to maybe wait a period of maybe a couple of seconds so that it should be available over here. Let's watch. Yeah, you can see the backup information is available over here. Let me just copy it to currently this backup is archived uh, and tarred and stored into the NFS. Let me just untar it and present it to you guys for this demo. Let me copy everything first for the demo to this from this directory. Okay, there are no files. Good. Let me copy this backup file to demo directory. Now just step inside the demo directory. Now we have backup. Let me use direct. Now you can see we have just untar this backup file. You can see the content of the complete backup, which is this NFS provider, which has been deployed in the default namespace, is available over here in the backup file. This is what is the progress of the cloud project till now. Shushan, could you please start sharing the
Yes.
PPTs? Yes, so this is what we have from our side on data management and data protection, and what works we have done to in Soda Foundation to uh, achieve the data protection for the container workload. And I would because this project is very new and there are a lot of things to be done. So we invite everyone to join us and join us on Slack. We can discuss in depth about design. We can discuss different requirements. If we have missed any requirement, you have anything to discuss, please join us on Slack. We love to entertain all the queries, and we also we can have an in-depth discussion on the issues you are facing. We have all the sort of foundation documentation available in the link, and please uh, uh, have a look into the code repository. If you find issue anything, please report us, and
Okay.
let's
Thanks, Amit.
create a framework
Thank.
for data protection. Yes, thanks,
Yeah.
guys.
Thanks, guys. Thanks for listening us and spending your time here. Have a nice day.